mass point. Oh, thanks. But I was gonna do something else like in circles, but I think that Eric already did that. So we are just going to do it with, we're going to pair it with complex numbers. And it's a little weird because normally you would expect that. And let me, okay, I'll stop writing myself. If you guys want to, let's see, okay. So today we're doing, okay, so let's see if I can remember. Okay, okay. I will also share with you guys all of these slides at the very end. Okay. Let's see. So, this one. Okay, so sorry for the delay. I'm just moving some stuff around. Okay. Okay. So, hi. So today is mass points. And what exactly is mass points? We'll see. But mass points mass points actually combines physics with geometry. Now, how does it combine physics with geometry? We'll see next. So our table of contents, I will first give you an overview, then give you some questions. No, I have water here. It's just that I am coughing quite a bit right now, which is really sad. I think actually recently I pulled a muscle based on how much coughing I have, but it should be fine for now. So this is my table of contents. It's overview, and then I'm going to go through this relatively quickly because I have a ton of stuff planned for complex numbers. So that's going to be quite difficult. Let's see. I also need okay. Okay, so next thing is, so mass points is a simplified method to use ratios of, to find ratios of given side lengths by assigning different points masses, commonly used in geometric problems involving Chevians. So it's Chevians because Cheva's theorem, which I think that Eric also taught this before. So we have a Chevian, and this AD is a Chevian. So that is a Chevian. And so when it comes to AMC problems involving only one Chevian, use ratio of side lengths to find ratios of areas. So basically what I'm saying is, do you see how we just need the ratio of BD to DC to find the ratio of the areas? Because the height is uniform. But when it comes to these questions I'm going to show you next, it's a little more complicated, let's just say. Okay, and then let's get to next. So basically in physics, we can balance objects of different weights on a seesaw by adjusting the distance from the center of balance. And this is something you guys will learn later in physics. But basically, think of a seesaw. So you know how a seesaw you can like, you can balance things, but if you move them closer to the center, they have like more or less weight, and that's similar to how I will how these work. So mass points works. So let's go to our first example, which, oh yeah, so we can think of a side length as a seesaw where the closer points must have a larger mass than farther points. Okay, so let's see if I can get annotate working, because I'm not sure if I can get annotate working. Okay, I forgot how to annotate this. Do you guys remember how to annotate? Because okay, actually, we're gonna sorry, we're gonna try something different. Let's see. It might be a little more difficult. So I don't know if I can annotate on here. Let me switch up really quickly. Oh, I see. Actually, I'll share. I'll just share. Okay, now let's see. Because I know how to share, but it's not letting me. Okay, wait, this is so confusing. So sorry. Okay. So, oh yeah, I see it now. Okay, now I can annotate. My bad. Okay, so now let's. Oh, you can't see it there. Ah, okay. I can try to. I should have had this all pulled out. Okay. Okay, now should work. So I'm gonna have to like move up and down. So the ratios of these is, so AD to DC is 1 to 2, AD to DC. So that's 1 to 2. And then let E be the midpoint and let F be the center of intersection. So that's point of intersection. When you see that, that normally means, okay, probably mass points. So let me see if I can remember. E is the midpoint of BD. Okay, so what we have is, let's start off, this ratio is 1 to 2. So how does it work? So one thing that people tend to forget is we'll actually have to put like the opposite side on the opposite point. So here you would actually write 2, here you would write 1, and then the center of mass is kind of easy. It's just the sum of this 2 beside it. So 2 plus 1. Now, okay, and then you know that these two are equal. So this would be 3 as well. So this mass point of the mass corresponds to this one. And D goes to this one. And that part is a little confusing. Sometimes people mix it up. But this is super important to know that that it's the opposite actually. So here it would be 6. You would find the sum. So then from here, since you know that the center of mass is the sum of A and F, you can also get that 6 minus 2 is 4, which is this. And it just so happens that this is 3 to 1. So 3 plus 1 is also 4. So we don't actually have to do any like splitting masses. Okay. So I'm going to quickly move it up. Okay, so area of ABC is 360. What is EBF? See if I can find it. So AB, I actually forgot it for you. ABC is 360, EBF. Okay, ABC is 360. So it's telling us that the whole triangle is 360. Now I kind of have to like explain it by example because it's really hard to explain it. Like this is a formula. You can't really do that with mass. So the area is 360 and we want to find the area of this triangle. Right? So how do we start that? Well, sorry. So one of the first things we can see is we can actually split this into like smaller triangles. So let's actually first look at ABF instead of EBF. So we're asking ABF. What's the ratio of ABF to ABC? Does anyone know? You guys can unmute. You guys know like the ratio of ABF to ABC? Okay, so Grace says 1 to 4. So that's actually exactly right. So here, you see the ratio is 1 here. So 1, 2, 3. It's not the exact side length. So 1 to 3. So, but the whole, how do I see? So do you see how ABF and ABC have the same height? So height doesn't matter, but the base length is what what differs. So the ratio of the base lengths is 1 to 4. So that is actually the ratio of the areas as well. So now that we know the ratios of ABF to ABC, we can actually find the area of ABF because we know the area of ABC is 360. So that means the area of ABF has to be 90 to hold that ratio. Now we can continue that and we can actually look at instead ABF to EBF because it's a lot easier that way. So now the height is again the same, which if you want to think about it, here's the height. The height is the same, but now we have to look for the ratio of the side lengths again, and we can see that that is 2 to 4 because this corresponds to this. So it would be 2 to 4. Actually, it would be 4 to 2. Oh, well, it would be 2 to 4 to this side length, but I'm asking for the whole side length because ABF has that as the whole base length. So it'd be actually 2 to 6. And I wrote the ratio backwards, but it would be 62. And we know that this area is 90, right? So, so we know that the area of this is 90, so that means the area of this to hold the ratio is 30, and that's what we get. That it should be the correct answer. And that was actually that was actually a little harder in the fact that we have to use areas as well. Normally it just asks you like, what's the ratio of this side length to this side length? So let's continue. Okay, so basically what here is you should avoid fractions or decimals when working with mass points because it's always helpful to watch for like specific points that have two ratios involved with it. And in this case, it was, did you see how I first did the D? Because the D was corresponding to both side lengths. That's what I was talking about. Okay. So, oh, this is the next example already. Okay, this is actually quite hard. Oh yeah, it is the next one. Okay, this one is actually quite hard. It's an Amy question, and because it's an Amy number 7 already, but that's the basic idea of a mass points question of how to find the ratios. This is much harder. So the reason why I gave you guys this question, well, I gave myself this question, is because like most mass points questions are relatively simple in that we can just look at this. Like, look, there's just like a Chevian right here. It's really easy. And there's like 2 points. But here we actually get this horizontal line, which this is technically not the center of mass. You can see my mouse. I is not the center of mass. So what you actually have to do with a lot of mass points questions when it comes to really hard AMC or Amy, you actually have to draw your own triangles because otherwise it doesn't quite work out as well. So let me see if I can. But see here, we're going to actually have to extend some lines, and I will do that right now. Let's see if I can draw a straight up line right there, and another one right here. So if you draw those two, now you can see, oh, it looks like what the Chevians that we saw before. So that is actually the main key. Oh wait, and I also kind of want to draw this line just to show you guys. There. Okay, so now that I've drawn these 3 lines, actually, I'm going to see. Okay, so we are given, okay, AB equals 21, 22, and then D and E are located on AB and AC respectively, such that DE is parallel to BC and contains the center of DE is okay, and contains the center of the inscribed circle of triangle ABC. Now, as a little hint, if you guys remember from, I believe, Eric's lesson, an incircle, does anyone know what an incircle is? The intersection of what types of lines? Like, I'll give you an example. Like, centroids are the intersections of medians. So do you guys know what it is for in circles? Type it in the chat. It, okay, oh, yeah, I mean the in radius, not the in circles. Sorry, that's right. Yeah, that's right. So what I'm asking for is like what thing and then I wrote in circle again. It would be the in center. Yeah, okay. Brandon actually whispered to me. He said angle bisectors, and that is correct. So that's actually a really important thing you guys should know, but in centers are the intersections of angle bisectors. And what that exactly tells us is that all the lines that like intersect here that we just drew would actually be such that these are the same. So I'm actually going to do double so you guys don't get confused. And is there something interesting about ratios with angle bisectors? You guys know? With like side length, side length ratios. I mean, okay, this one might be slightly like, but basically the ratio of this side length to this side length is going to be the same as the ratio of this side length and this side length. Okay, wow. So now that we have a lot of information so far, we can start with mass points. Okay, so generally you want to avoid fractions, but here we might actually have to go to like pretty nasty fractions here, just because these numbers don't work out really nicely with each other. So we know that the ratio of this side length to this side length is, it's going to be 21 to 22. So 21 to 22. This is going to be slightly smaller. So the center, this is going to be the point mass because it corresponds to the opposite one, 21, and this is going to be 43. I can't add percent. 43, right. Now we can do the same for this side now. This side, like we did it with the bottom, because this is also an angle bisector. If you see, and this ratio would actually be, let's see, this side would be 22 to 20, right? So this would be 20, this angle, and then this would be 42. Yeah, if I'm not mistaken, I'm gonna write something so it doesn't quite as crappy. And 42, and then here it would be add 20 plus 21, which is 41. If you guys are confused, just like ask about it because it does get a little confusing after a while. And if you like add every pair, you end up getting that the middle is 63. Which is really nice because now we don't have to quite as much work with like fraction. Well, splitting masses, which you guys will see later. And it has appeared on AME and AMC questions, so I will teach it anyway. Okay, so, but the question asks you the ratio, sorry. It asks you for the length of this side. So how does mass points help us with this? Okay, so one thing we notice is that DE is parallel to BC. Notice that we need to use every single piece of information to give us. So now that we know that it's parallel to BC, that implies that ADE is similar, and this is how you write similar, to ABC. Okay, great. Now, what is the ratio of the area? Okay, so I believe that it is like especially if you look at this side, this middle one, which I just wrote with blue, we can see that the ratio of this is actually, I believe, 43 to 63, right? So 43 to 63. Now, why is that? Because this one corresponds to this, and 63 is the length of the whole thing, so the ratio is actually 43. the length, this is not the area ratio, it's 43 to 63. So, so we're trying to find DE. DE would be the smaller one, so 43 divided by 63 times the side length of BC is 20. So when you multiply it out, you get 860 over 63. And if you add that up, the actual question asks you n plus n. If you add that up, you get 923, which is the correct answer. Which for here, it might be a little confusing on this part, but we'll have to use this ratio to the whole thing. I wonder. Oh yeah, and you can't use like these edge like ratios, because it only goes to here, not to here. So we don't have like this. If we had like whatever mass point of D and E are, then we can use those silents as well. But since here only we know the point mass of 63, we have to use this middle silent. And that was actually a little harder because it's an AME question than you'll see on AMC, but you know, you never know considering how hard they are getting right now. Let's get to the next one. Okay, so here are some tips that I have for you guys. So use what you know about similar triangles and their ratios. Did you see the question we just went through? So in that question, we used the fact that they were similar triangles, and then we could use mass points. So not all problems will directly just give you the exact ratios, because they're a little tricky. Oh, oops, did I go backwards? I sent it forward. That's my bad. Sorry. There. Okay. Mass points only helps you with the ratios of side lengths. So if the problem asks you for the exact side length, as you saw here, we couldn't use just that ratio. We had to like use some of the other information given, or we had to use something different, but it won't give you the exact answer. And it also might be helpful. So you guys shouldn't just like cross it out. If it asks you for the exact side length, don't just immediately think that mass points will work. And then angle bisector ratios and ratios from the centroid. That has appeared on AMC, where the ratio of the centroid can help you with mass points. And if you remember that, I know that Eric, I searched it up, but Eric had his basically centroid split medians into a 2-to-1 ratio. And using that can obviously help with mass points. And then we also have the don't get the ratios mixed up. This is like the worst, because AMC tends to give you both of the ratios, and you have to make sure you know exactly which one is for which side length. One easy way is to check is just to like guess like, oh, which one is slightly longer, so then you don't get your ratios mixed up. And then look for triangles. So this one is actually one, the last tip is actually one that you will see a lot more in later questions for late AME or mid AME and late AMC as well. If it looks more like a quadrilateral, make sure you split it into triangles, because mass points really only applies to triangles. You can't really use the seesaw method on a quadrilateral, and it can result in a lot of like wrong answers if you do try to do it on a quadrilateral. And you'll see in one of the following questions. So not all ratios will end up nicely, and this is where we come into splitting masses. So this is actually a newer concept, because I'm pretty sure Vestavia doesn't teach splitting masses. We do teach mass points in our geometry curriculum, but not splitting masses, and it has appeared on AME. And I don't know if that's on AMC, but it's good to know. It's not actually really difficult. It's just to know. It's good to know. And this is an example question. So, great. And here's our diagram. So, let's start off by making some ratios. Now, the issue with this question is like, is that you don't want to end up with like nasty numbers here. So one thing I like to look at is I'll look at one specific point and I'll see, okay, so this length course, these two lengths correspond with the point mass of B. So since 2 is divisible by 4, I think no, 4 is divisible by 2. Sorry, I can't talk. But 2 is a divisor of 4. It's more smart if we put like 4 here instead of 2, because if we put 2 here, it would cause some fractions along the way. Normally I find like the LCD kind of. Okay, so then this would this would be 3. This would be 7. This would be, okay, actually no, we start here. So 4, this would be 10. This would be 14. This, okay, we're already seeing some issues here, if you can see. Like, because the ratio of this to this is not 3 to 10. And that's where the splitting masses comes from. So what we actually get, I believe, is, okay, so you would get 21. Right? And then you would get, let's see, I think 17. It gets quite nasty here. Okay, so, and so it would, let's see which side would need the splitting masses. Okay, 3, 7, 4. And I think it was, let's see. Let's see. I forgot what it was asking for. It was asking for find the ratios EF to FD and BF to BG. EF, oh yeah, I have it here. EF to FD, and that should actually be quite simple. It would be EF to FD is not the issue here. The issue I think is C here. So C is where we are going to have split masses. And basically that does is or it could be A here, which is why I'm like thinking. I forgot what I put. But I think it would make more sense. The issue with splitting masses is you have to determine which side length is the one where you have to split masses. And I actually think it might actually be side B. But I like so well forgot this question, if I'm being quite honest. I forgot the answer to the question. So maybe I'll try like something different. Maybe it's like 21. So you actually have to test it out here. What? 21. 21. It doesn't quite work as well. Okay. It's okay. I slightly messed up here. Somewhere I messed up. If anyone can see like where is that? Because what I should end up with is that this middle one shouldn't be wrong. That's the thing. 17 over 10. Maybe it isn't wrong. But basically what will happen is that I'll say, okay, 3, so 3 sevenths, 3 sevenths, we would have 9 sevenths here, right? To keep the ratio, I believe. Yeah, 9 sevenths. And basically what you do is you would combine the masses here. So you would combine the masses here. So the point mass of C wouldn't actually just be 10 or 9 sevenths. It would be the sum of the masses. So here it would be 79%. But I think this should work out. But I'll show you in the next one because I know for sure. But this one is basically for splitting masses, you would add the different masses that were created, and that would be the total point mass of that question. So if they ask for like the ratio of some other side length to that, it would be the sum of it instead of just one over the other. So let me get to the next one. Sorry, I'm like rushing through this because I have a complex numbers is a really hard topic, and I wrote a lot for that one. So I'm going to rush through this one. So I think this is actually the last slide, and this is also an Amy question, as you can see. It says Amy. So I will draw it out really quickly, and I wrote it out because look, it says parallelogram and not triangles. So you actually have to split it into triangles. So, oh wow, I didn't call that. AF, let's see how well I can draw mine. Nice. Wow, that was a really nice parallelogram. Okay, so A, B, C, D. C, D, M is on AB. Such that AB is 17 to 1000. So it's like that. Okay, so No. Okay, so now we get that, and then you have to draw lines. So AN to AD, which one thing to notice here is it's AN to AD and not ND, so you would have to notice that. Here I think we see that the point of splitting mass is at A. So that's like the point where you have to split masses. And like I said before, we need to create triangles for it to work. So one of them is going to be this. Oh, it's not drawing, which is strange. But basically, you'll have this line and this line. And you have to draw these two lines because this creates triangles. Okay, so 17. Okay, so point mass of here would be 17. This would be 1,000 minus 17, which is something, but you know this is 1,000. 1,000. And then this is also 2009. This is 2009 minus 17. So you get, this is 3,009 as the ratio. And this would be 3,009 minus 34. And I believe that is actually, let's see, that's 2,975, right? Okay. So, AC to AP. So we're trying to find the rate. This is P, by the way. So we need to find this length. The ratio, but notice, okay, this is something cool that you guys notice. But this, notice how this side length is the same. It's the same as this side length. So we just, if we can find the ratio of this to this like red portion, then we can, like this small red thing, then we can just like kind of double it to get the whole thing. So the small one, okay, so, oh, I actually messed up the ratios, my bad. This is why, this is 17. This is 17. You swap them, my bad. Okay, 1,000 minus 17, and this is 2009 minus 17. Wow, I'm so sorry. I don't know like how I managed to mess that up. And I didn't notice it until later either. So so then you see that by splitting masses, no wonder I was like, there should be splitting masses here, but there is. So this is where A is the point of splitting masses, and you would add these two up. So the point mass of A would actually be 2,975. It wouldn't just be one or the other. Yeah, so 2,975 is the splitting mass of A, and then for this it would be 34. So you would take the ratio of AP to P, let's say this is O, it doesn't really matter. PO is 2,975, right? Oh, I think it asks you for the other way around. But that would be 2,975. But we're actually asking for A to O, not just P to O. So we'd actually add 34 to that. And you would get 34 over 3,009, which I actually swapped it. It asks you for AC over AP. Doesn't really matter. I can just swap it back. So 3,009 to 334. But the thing is, this top part should be doubled because AO to OC is the same. So you get something like 3,009 over 17, which gives you 177. So that is how you solve that question. This one is also a little harder of mass points. I actually swapped it. That's why it's super important to see how like the ratio of the side lengths, you don't mix it up. It's like swapped kind of thing. Okay, my voice is dying, but I will give you guys questions after this class on both math points and then I will show you the next one. So actually, I'm just gonna do it. Oh no. share really quickly, which it doesn't quite matter. Okay, complex number. This is not right. It should be this. I don't know why it's called. It should be complex numbers. And bring you all the. I use overleaf, which is like it uses LaTeX, and many of you guys should learn LaTeX if you don't know it yet. Try to learn it. You can also use Word if you plan on teaching later, but LaTeX is the way to go because a lot of if you plan to apply for math camps or certain things like USA and TS Talent Search, they all kind of like typically people use overleaf and also not overleaf LaTeX, and you will actually gain extra points for using something like that. Okay. So yeah, so that's what it is. I can also kind of help with LaTeX if you're kind of new to it. So now I can go back to screen share. I'll just screen share. Yay. Okay. So this is again me. Oh wait, not yet. Can't see it yet. Okay. Yes, back to me. This is complex numbers now. I'm so sorry. I kind of rushed through math points, but complex numbers is a lot more difficult because this is algebra 2 and and pre-calculus. Sorry, pre-calculus curriculum. A couple things you guys should know about this. It's actually like I realized it used to be a topic. It got squeezed out because of some other people want to do like triangles one, which is I think actually slightly more important. This one is also very helpful for I believe AMC 12, actually more so. It also helps with AMC 10. There have been AMC 10 questions that have focused on complex numbers, but you don't exactly need to know like slightly more complex stuff about complex numbers. But on Amy, it appears so often, at least once per year. At least once per test. Like you can search it up. Literally, there's like a whole list of complex number stuff on Amy. So whether you like it or not, we're gonna go through complex numbers. Okay, so I'm gonna go through basics. I didn't name these very creatively. So one of the first things you see is is that okay, obviously for most of the people who are new here, this is the form a plus bi. That's normally how you find it. C plus di. This looks really complicated. It's not. I'm just saying they have to be real numbers. You can't have b plus I or something. And yeah, so that's the form that you're taught in like 6th, 7th grade. You guys should know this. And then addition, make sure for most complex numbers questions that you specifically divide the real and the non-real portion. So the imaginary part here and then the real part here. So, and then this is addition, subtraction, and then multiplication FOIL, which is like basically just multiply it out. If you don't have to memorize these, this is just like division, you rationalize the denominator. It has appeared on MC before. It's quite weird, but yeah, make sure you know division is rationalize the denominator and the conjugate. Okay, so the conjugate is that actually most important part of this lesson. You have to know what a conjugate, especially in AMC 10. For AMC 12, you'll have to know the more complex stuff, which I will show you next, and you'll probably be slightly confused, but that's it for basics. So here's actually an Amy question. This is actually an Amy question, and I'll give you guys like 3 minutes to solve it. You don't have to solve it, but here's an example question. And you guys can take some time to come. Okay, I'm gonna come back and I'm going to like explain. So nobody got it, but that's okay. So there's also a little less people because I don't know if you've heard, but Vestavia is hosting a novice tournament today, speech and debate. So there's a lot of people at that currently. And okay, so I have the solutions here. For this question, you don't actually need any, like you just need to know a plus bi and split it like that. So I have the solution. I typed it out. So the solution is a plus 164i, let z equals a1 plus a plus 164i. And then and then once you get this, you can you know that a is a real number, and you see that the imaginary part 164i, that's where we got that, and a positive integer. So that's why I specifically paired it with the a, because a plus n, this part is real. So it's the part of the real part, and then there's the imaginary part. So a plus n plus 164i equals 4i. You cross multiply it, and you get that this. Okay, this is super important that you make sure you always pair up the imaginary part, the part with the I, and the part without the I. So then you can see, oh, it has to be, oh, I actually put 864 here. It's actually 656. Oh no, undo. That was okay. Back to, sorry, this part is actually 656. I will have it fixed. I realized I made a mistake. I don't know where I got the 864 from. 656 here. I fixed it here. 656. And you get that a plus n has to equal 41. So n equals 697. That's how you get this question. It's not too bad. Okay, so let's go to the next one. Now I'll have that fixed. Okay, so I have a lot of questions here, so we might actually slightly cut into your like group work today, because but I have a lot of examples, so maybe we can slightly compensate for that. So our magnitude. So we define the magnitude for as like root a squared plus b squared. You guys kind of recognize that from like Pythagorean theorem. So yeah, so it can often be written as this like absolute values, right? Now, the real part of complex numbers, it's important that you guys know this notation. It's kind of like self-explanatory, but it has appeared in AMC like this formation, this written like this. So the real part of Z, which is the A part, and then the real part of the imaginary, which is B part. If you guys are confused on anything, feel free to ask me. I'm going to slightly rush through this again, but because I prepared way too much, honestly. On axis, it's okay. Trigonometric representation. Okay, this part is the part where it gets advanced. You will learn this by definitely algebra 2, but you will have to know this. Basically, this is also used in calculus. So r cis theta, where it's coming from cosine I sine theta. So that's what it is. And then times r, obviously. So you're writing it as r cosine plus r sine theta. Now, why would you do that? Well, you're going to see later that this is actually a really nice, geometrically, it works out super nice. And the reason for that is that it's going to be like it's going to be on a circle, and that's why I paired it with math points, which is geometry, because complex numbers in Amy will have a lot of really nice, the way how it like looks, it's going to look super nice. So polar representation, you're not going to see this as much. It's just like r theta, where like r and then cis theta, that's where the theta comes from. Yay. So this is super important as well. Make sure you know that this exists. Oh, that was so sloppy. But like I can prove it right here, like a plus bi times a minus bi. It's actually gonna be squared. Oh, I messed up. It's actually gonna be squared here. Oh my goodness, I made a lot of mistakes here. But it's gonna be a squared plus b squared, which is also happens to be the square of the magnitude. And that will be because I did not know that. And then we'll go to next one. Okay. So the Argonne plane. This is called the Argonne plane. Many of you guys will probably knew this plane already. It's just you didn't know the name. It's called the Argonne plane, and it's used to graph. Basically, you graph the imaginary part. So here, it's x plus yi. So the y is graphed on the y-axis. The real part is graphed on the real x-axis. And this is going to be super helpful, obviously, with the geometry of this AMC questions. And now we're going to go to the actual teaching part. Okay. If you guys think I'm too fast, I will slow down. But this part, it gets really, really fast. So let's redefine. Basically, earlier I told you, okay, this is addition, subtraction, multiplication, division using a plus bi. Now we're gonna substitute in the fact that a equals r cosine theta, and b equals r sine theta. And basically what we learn is that when we multiply the magnitudes of two different complex numbers, it's gonna equal the magnitude of their product. But this is not right. So do not fall into this pitfall. Okay, it's actually related to the triangle inequality, which is this. So, but it will not equal it because if you think about it, like you have two things, you have two lines, and if you connect them, they can't be equal to each other. Actually, I think it's but unless if their angle is the same, which I think I assume that the thetas are different. So if we let, oh my goodness, if we let W and Z equal this following, then if you multiply it, you're gonna get that this is true. And and the same thing works if you divide it. So, and again, this should not be there. Okay, so I'm gonna keep going. Oh yeah. Oops, actually I had a question on the very bottom that I forgot, I didn't see. But basically I wanted you to find the product of these two numbers. And you can see that by using cis theta, it's kind of easier with the angles. But for this type of question, it's easier if you just multiply it out instead of just using whatever cis theta I just taught. I'm going so quickly. Okay, De Moivre's theorem. I wonder if De Moivre's theorem. Am I going too quickly? Is this idea of changing r cis theta into x kind of complicated? This having the thetas add together might be a little complex. But when you with angles, it's adding for multiplication, and division, it's subtraction. You just have to know that. And for the reals, it's the same as normal. So you multiply for multiplication, divide by. So De Moivre's theorem is actually an extension of multiplication. Basically, we're multiplying this number multiple times. So you're multiplying multiple of these r's. So when you multiply this number n times, you're gonna get that the r to the 1 to the n is gonna be to the n, and that these cosines are gonna add up. So we're gonna keep adding the thetas, and this is notice that these thetas are the same, by the way. And so then you'll get b to the n equals r1 to the n cis n theta. Now, why is this important? This is actually the most important part you should know if you're going to learn advanced. You have to know this, De Moivre's theorem for AB. You have to know it. Whether you like it or not, you're going to have to get this idea of cis theta. But you don't actually always have to use De Moivre's theorem. And here's a sample question. Sometimes you can just find the first couple of values and then find a pattern. So don't make it hard on yourself. Notice that De Moivre's theorem only works for multiplication. You can't just use it on addition. Addition, if you have addition involved, use a plus bi. But here's a sample question for you guys. I'm going to give you guys 3 minutes again if you guys want to solve it. And feel free to talk out loud. Okay, if you don't know like exactly what to do, write out the first couple of terms. So write out Z1, Z2, Z3, and so on. You see like a very obvious pattern soon. So that's your hint. You don't know.
Hey, Carol. Oh,
Hi. I don't know who that was. Oh, was that Albert? Okay, I'm gonna just solve this question so we don't like cut into. By the way, I came in actually quite late. So this will kind of go over. Maybe like 15. I will approximate about 6. I will finish like 6:10-ish. Okay, I didn't plan that many questions, so it's quite okay. So so basically you just test the first couple of values and you get 0, I minus 1, negative I minus 1. You get like I minus 1 over and over, I minus 1 and negative I, like, and they just keep repeating. So then you get that, oh, I minus 1 must be Z, which has magnitude. So the answer is root 2. Okay. So if you learn anything from today, learn that you can use the sys theta function to rotate points and shapes. And that's super important because in matrices, they also do the same thing, but we're not going to use matrices. We're going to use sys. So sys helps you rotate. So let's say you want to rotate 4, 6, 60 degrees counterclockwise about the origin. This is even helpful in like math like competitions, like local competitions. It is helpful. So when you're wanting to rotate like 4, 6 or something 60 degrees counterclockwise, remember that it rotates counterclockwise. Remember the direction it rotates in. Then you get a point that's 60 degrees from 4, 6. So and note that, okay, let me draw it out actually. So let's say you have like these, you have a point, oh my goodness. But you have like, right? And you have a point that's like here. It's gonna rotate 60 and you multiply by 60. It's gonna rotate 60 degrees. But notice that the length still stays the same. Like these lengths are gonna still be the same. Now the reason why is because when you multiply by 60, the radius is 1. So when you multiply the radii, the radius, like if you multiply by like r cis like theta, when you multiply it, remember that it's gonna be r times 1 cis theta plus 60. And that's where it's coming from. So it's gonna rotate 60 degrees this way. Yeah. And the radius is still gonna stay the same, unless if you multiply by like 2 cis. Then this length is gonna double. Yay. Okay. Now, this is also an Amy question, but do you notice how it says vertices of an equilateral triangle? The moment you see that and the fact that 0, 0 is one of the points, you should immediately think of, oh, you can just rotate this one this way and you get this. Yeah, so once you rotate that, you should get this point. And I want you to do that. So I have the solution as well. So change it into complex numbers. A plus 11, A11, make this onto like the argon plane. So A plus 11i and B plus 37i. Then you know that A plus 11i times cis 60 must equal 37i. since the magnitude is the same. So when you multiply it out, you get this, which is still really nasty. But once you set it equal to like the real part of A and the imaginary part, you can easily get this 315. And now, like this, even this question, like it looks relatively simple with like using the sys function, but this is a number 9 on A. So like this is really hard. But like if you learn like sys, and these questions appear on AMC. So it's like, because if you look at it, it looks like it doesn't have any complex numbers. But if you use complex numbers, it becomes infinitely easier. Like try to solve this using geometry. It's gonna be like, oh, you're gonna use like, sorry. You're gonna be using like tangents and these angles, these y values are not nice at all. And it would take so long. Like this value is quite hard to find. But if you just use like complex numbers, it becomes a lot easier. And like the thing about AMC is that it says it doesn't require like trigonometry. But the thing is, like, if you use trigonometry, it becomes so much easier, which is why you should learn trigonometry for AMC 10. Even if it's not necessarily on the curriculum, a lot of the times, like, there's like so many questions out there that I could show you, and it's so much easier with trigonometry than if you try to like I don't know, bash it out or something. Okay, roots of unity. Now that is the part where it's gets a little scary. And even like AMC calls it roots of unity in AMC 10. Oh, not AMC 10, AMC 12. This is mostly AMC 12, but on AMC 10, it might ask you for like it has appeared on AMC 10. I have some questions in the practice handout that I will give you guys. And it will show you some AMC 10 questions that use this. So how can we use complex numbers to solve this? Well, how do we solve this? So roots of unity satisfies this. Now, why can we use complex numbers? Well, obviously one of the answers for x is going to be x equals 1. And why can we use complex numbers to solve this? Well, remember our oh my goodness, our division algorithm I showed you guys from the beginning, where you like, if you have like cis theta or something, or like r cis theta, and you want to divide it by like some numbers, then you could just do like r1 over n cis theta over n. And that's super helpful because this is one of the roots. This is going to be one of the roots for this equation. And if you continue, you can also get 2 over n. That's also. But we're not here to like look for the exact thing. I'm just going to show you guys the importance of the actual shape, because this is where the geometry comes from. Okay. Oh, oops. Actually, I'm going to show you guys something wrong. So let's try to draw out. I'm going to try to draw out the roots of x squared minus equals 1. Okay, so you get x equals 1 and x equals -1. Wow, so it's just a line. It looks kind of boring, honestly. So we try again. Okay, I mean, it doesn't look quite boring, but it just looks like this. X cubed equals 1 is going to be a little different. So x cubed equals 1. I'm actually going to just show you guys the solution. You guys can learn how to. The answers are cis 360 divided by 3 cis 360 divided by 3 times 2. Oops. And then cis 360 divided by 3. The 3 is coming from the x cubed times 3, which is just 1 actually. We have 1, and this is actually like, okay, I think this is like -1/2. Yes, it is -1/2 plus root 3 over 2i. You guys don't need to know this. I just here to show you an example. Should be -1/2. Oh, I'm so sorry right now. -1/2. And then instead of plus, it would be minus root 3 over 2. You guys need to know that as well. But let me graph it. So let's graph it. 1 here, -1/2 is about here. And the 3/2 is actually very close to 1. It's here. So what shape does this make? It makes a triangle. Now, what exact triangle does it actually make? It makes an equilateral triangle, actually, which is super interesting. And that's going to hold for the other one. So that leads me to my next question, right? Which is, what shape do you guys think x to the 5th will make? You guys can just text me. Whisper to me. You guys are really quiet. So quiet. Such a quiet class. Just like whisper, like what shape do you think it'll make? And what do you think? Oh, the second question is if you're done with the first question. Yes. You guys are absolutely confused. Just remember that x cubed equals 1 creates an equilateral triangle. And then x squared equals 1 creates a line. And then x to the does anyone know? I don't know. I feel like I have absolutely confused you guys. But it's okay. I'll show you guys the slides and you guys can look at it later. You have to do this stuff. So it actually creates a pentagon. X to the 5th pentagon creates a regular pentagon as well. So, and x to the 5th I also creates a pentagon. Which leads me to the next example. Okay, so z plus x to the 8th equals 81. So for one of the first things I want you guys to like wonder is like what regular pentagon does it make? You guys know what regular pentagon does this? Honestly, you just have to look at the power. You don't actually have to look at the Yeah, Grace is right. It's an octagon. This is also a late ANC question, so it's 20 something. It creates an octagon. So let's draw an octagon. Oh no, my drawing to the test. Hey, this actually looks horrible. It's been worse. Okay, know that none of this numbers actually matters. This actually just tells you that the center is actually at -6, but that doesn't affect the area. Just for the area, what is the least possible area? So literally you get a regular pentagon and then you're just asking, okay, geometrically, what is the least possible area of ABC? Like, technically it's this one, this tiny one. That tiny one. Now, okay, finding the actual area of that triangle, of that. Oh, and we also have to know the radius. Do you guys know the radius of this? There's a really easy way to find the radius, but it might be really confusing. The radius is actually, you just take everything to that like 8th root. So you just do this 8, right? And then this becomes z plus 6 equals √30. And that is the radius. The radius is this. And then you find the area of that triangle, and that is super easy. So that is a lot easier than whatever this was. So that is all you need to know for this question. The rest is just like pure geometry, which is a different lesson. Next. Okay, I was planning on giving you guys this example, but I think we're running low on time, so I think I might. Do I have the solutions here? Oh, I do not have the solutions. Oh, because this is the last slide. That's great. Okay. I might give you guys this for practice. And then Okay, so I will give you guys a document. I will split you guys into breakout rooms. We might run a little over time. Feel free to I'm gonna please tell me your grades too, because we're gonna split you by grade again. Just whisper to me what your grade is. What, and I think I'll split to like middle school, high school, because there's not that many people, and I will share with you the doc that I have. I have 2 docs today. The first one. Oh my goodness. I'm so sorry, guys. I've been like sick for the past 3 weeks. Okay, yes. Just whisper to me your grade and I'll split you into 3 different groups. And oh no. Let me see. Oh, here. Oops. Okay, I have 2 that I'm going to give you guys. First one is going to be. Oh, oops, I actually sent it to only 1%. That is the complex numbers one, and then the math points one is slightly shorter. I also split it into easy and difficult. I will, by the way, all these questions will be on the Discord. I will, and along with the slides. So sorry, my voice is like horrible right now. Okay. And I will also share math point questions. If you guys can't see it, just whisper it to me, and then I will. I think most people here are in middle school or high school. Okay, yay! So I'll just put it like that. Okay. So everyone's like nearly the same grade. That's crazy. Okay. Okay. And then I just need Eddie to give me his. I think Eddie is in. So. Yay. Those are the breakout rooms. And then I'll and then me and like Taniko who can like go to the different rooms.
I guess.
Hey Brandon, so do you know which questions we're doing today? You know, I
Uh,
found the lesson very interesting. It was
yeah, that was extremely
very
interesting,
challenging.
actually.
The topic it seems very interesting to me. Seems
Oh,
very
yeah,
fun.
yeah, it was extremely interesting. I knew everything. Yeah,
Yes, sir.
honestly.
Do you have the questions for today?
Yeah.
All
I'll
right.
just let me see if I can share it.
I have them. All right, so is it do you see like the complex mass points thing?
I see the complex numbers, and
Oh,
to be
okay.
honest, I don't understand the math points, but anyway.
Yeah, honestly I didn't understand mass points. Like there was a bunch of trigonometry and I don't even know what that is.
All right.
So let's work on complex numbers here. All right.
Yeah.
Okay. Let's do number 1. Bro. Albert, give me some
I'm
paper.
definitely not cheating right
On
now.
this. Wait, are we allowed to work on this together or no?
Yeah.
We are?
Yeah.
Okay.
Fine.
I got 64 plus 64i.
Yeah, that seems about right.
That seems extremely
You guys
right.
seem about right.
Well, I swear, when you guys step on my computer, I'm actually gonna kill.
Why do you have your computer on the floor in the first place? Okay, number 2. I'll do number. Actually, I don't think I'll do number 2.
It's actually
I
a
can do
pretty good
number.
point.
Yeah, I can do number 4, probably. Number 4? Wait, are you on number 1?
Can I have a suggestion? I think you do all the question together. You should not do this question individually. I think it would be better you guys discuss every questions.
Oh, yes,
Right?
sir.
Yeah.
Alright, let me
Otherwise,
check.
you learn more if you guys discuss together, right?
Alright, yes, sir. Let's
Yeah.
work on number 1, guys. Everyone, start working.
Do you have the questions? Do you
Yes, sir.
you have the question? Okay. All right.
Complex numbers, right? September 2022.
Yeah.
You can
that's-
share.
Um,
Do you guys want to share? Let's Albert share the question, right? We can.
Okay. Question number 1 is 1 plus x to the 4. No. 1 plus I to the 4th power times 2 minus 2i to the 3rd power.
I agree. So this is just you just literally just working this out. There's not really anything hard.
Yeah.
Just
You
just
just
work it
use
out.
like the whatever the like the little
oil
bin-
or whatever.
Yeah.
Yeah. A plus.
And what did we all get? Albert, what did we get?
So 1 plus I to the power of 4 is wait, never mind. I got something wrong.
1 plus I squared is like yeah.
All right, guys. I looked at number 4 and I got that one, but
Wait, what?
I know we should be working out here. Let me do number 1 real quick.
I got 64 plus 64i. Just me personally.
Let me go. Let me get a piece of paper.
All right. Yeah, because like 1 plus I squared, that's like 2i, right?
Yep.
And then that square that
Yes,
you
I got
get
64 plus 64 I too. I think it's 64
Alright.
plus 64 I.
Yeah.
Yeah.
All right, let's go to number 2. Okay.
F Z
Okay.
F to the. Does that mean you do it one foul?
wait.
Okay, sure.
Wait,
Okay.
I don't know that. What is that syntax?
I don't know either.
Dude,
So is it like
Kind of
You're
read.
a racist.
yeah, that's actually kind of
okay.
It's kind of hard.
There's probably a pattern. There's probably a pattern. Yeah.
so is this like recursion or something?
Okay. Okay. Oh, by the way, you guys can discuss. You don't just have to send me the answers. I will check your answer though. Okay. I'm pretty sure you are right, by the way, Grace. You're right. Okay. Grace, actually, I just came back, but your first one is slightly off, by the way. My bad, I just checked. But it's slightly off. You're very, very close to.
be right actually. That's kind of goofy.
Question's very interesting.
I'm on number 6, and
Yeah, I'm
It's
the
not-
number 6 too.
not
All right,
clear to me.
Carol, for number 5, is
Yeah?
half will half plus I to the 4th be
Oh, number
considered
6
from
is like really
half
hard.
plus I to the 8th? Or no, I plus half.
I have no
Whatever.
idea what you're talking about. Number 5 on what question?
I only find 2 complex numbers in number.
Hey guys, Raymond's microphone cannot work. Maybe he cannot talk. But Raymond just post a question in the chat. Grace and Darwin. Okay, good, good. Grace, you can talk, but Raymond microphone cannot work, but you can talk. Grace and Darwin, right? You two can talk. So the other breakout room is very, very active. Everyone talk. This breakout room is so quiet, right? Guys, just talk to each other. The other room, everyone is very active in talking. You need to talk to discuss, right?
I split the 1 plus I to the 4th power into 1 plus I times 1 plus I to the 3rd power. And then I split the 2 minus 2I 3rd power into 1 minus I 3rd power times 2 to the 3rd power. And then I combine the 1 plus I to the 3rd power times 1 minus I to the 3rd power. And in the end, they got to 2. So then it's 1 plus I times 2/3, that times 2 to the 3rd power times 2 to the 3rd power, which is 64 plus 64I.
Yeah, great. Raymond get the same answer, right? That's great. Let me call Carol to join your breakout room. Carol is in the other room because there's a very active discussion in the other room. Carol cannot leave, but I will ask Carol to join your room. Okay. Let me talk to. Where is? Yeah. Okay, I will let Carol come here.
Oh yeah, by the way, Brandon, number 5 is actually quite difficult. Well, it's not that difficult, but like number 1 and number 2 on the difficult portion might be actually slightly easier than that question. But I can't tell you the solution since you've been working on it so long.
Carol, the other room may need you. They
Oh,
may need
okay.
your help. Yeah.
Oh, what the heck?
Okay, Carol will come back later because the other room
By the
need
end.
her help.
Huh? I think I got 12.
Okay.
Oh yeah, we were just told we had to talk to you, Brandon, about this math question. Which one are you on right now? Sir? Shut up. Which one are you on right
Actually,
now?
I'm completely done with it.
Brandon, which question are you on?
I'm finished with 5.
Oh, number 5? Okay, I'm on number 5 too.
Surprise, mother.
Dude.
What are you doing? What are you doing, Isaac? But like 1.2, number 1, polynomial.
Oh, then that is actually unfortunate.
Uh-huh.
It's actually really unfortunate.
Uh-huh.
Mm-hmm.
Okay.
All right. So what? Mm-hmm. All right, 2i to the 4th. That's gonna be 16, right?
Restart. Where is it?
It's like negative 8i a. Negative 8. Will be plus 2xi plus 2i equals to 0.
Okay, so for number 5, I basically like
I got
all right, so number
12.
5, like what did you do? Because I basically did 1. Wait, never mind.
Oh, I just did some stuff. That's it.
I did 1 over a plus bi like equals 1/2. Oh, 1/2.
Oh wait, no. But by the way, it's supposed to be z to the 24th equals 1.
Huh?
It's supposed to be z to the 24 equals 1. Yeah, Carol did a goofy
Wow. Okay. Okay. Yeah. Z to 24 equals 1. Okay.
Yeah. All right. I think you should split it up into like z to the 12 equals 1 and z to 12 equals -1. Split that up. I'm literally using a crayon right now. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Actually,
Brandon, total how many questions Carol give you?
there's
How many?
6 for the easy and 7 for
Oh.
the hard.
Okay. Yeah, and right now you are working on the number 5.
I think I figured it out.
Number 5 or number 6?
5.
Number 5. Okay.
Hmm. Yeah, 24th equals 1. It's gonna be like a 24 gone.
So you already get the answer for number 5, Brandon?
Yeah, I think I got 12.
12. Okay, Albert and Isaac and Harry, have you got the answer for number 5?
Yeah.
Yeah, we all
I
did.
don't really know how to do it yet.
5 is yeah, you know, we were looking for it, but then I went to do some. You went to use our
What?
term.
So Brandon already get the answer. Maybe Brandon can explain to you.
This
Not really. I can't. That's actually a fair point.
6,
No, number 5.
number 5.
Yeah.
Oh, I've done that before. You graph roots of unity, and then it's the same. Let me think. Because you take it to the 6th power, so that means there are 6 roots in x to the 24 equals 1 that equals 1 when taken to the 6th. That
And
doesn't.
there's-
If you know,
and it's the same for the -1, right? Or
there's
I don't-
bound to be more than that.
yeah, I got 12.
How'd you get 12?
I got 9. What?
I got 9. Yeah.
I got 14.
I got 3.5.
Oh.
But what did you get again? What'd you get again? Isaac, what did you get again?
9.
Oh, I got 11.
How the heck do I draw a 24 gone?
You could just draw a hexagon and then
What?
What's
And
a
then-
hexagon?
I don't know what that is. Sorry. 20 for Aegon.
I think we need Carol to help us. Yeah, because like
Ah, what is
Sure.
this?
What?
yeah, if we get Carol in here, we could probably do a lot better. I'm saying. Carol's a
Okay, I will get Carol to join your room. Okay. Let me call Carol here.
Roots of unity.
So Carol, do you have time? The other room also need you. They are get stuck on number 5.
Yeah. Okay. Yeah.
So quick question.
Um,
So can we extend can we extend the time? Can the burger
yeah.
so there's no time limit, right? For the burger
Yeah. You guys
room,
can
right?
keep working on it until.
Oh, okay, good, because they are working on that. Okay.
Okay.
Could you join the other room? They need they
Yeah.
need you. Okay.
By the way, Raymond, you are actually slightly off. So I didn't want to say that, but yeah, slightly off. Actually, you're quite off, but I see your idea. You should. Albert left the meeting. Is he supposed to leave the meeting? He just left.
Okay, Carol, I will tell them to join back. Okay, I will tell them. I will go there tell them.
Okay.
Yeah.
What the heck?
Okay, yeah, they are joining. They are coming back. They are coming back.